Hi, my name is Nicolai Moore.
I'm Arya, Parvaresh.
I'm Beken.
I'm Ben Bolt.
Hi, my name is Ahad, and our group created a program to advise the property owners on the integration of solar power. So some of the background slash introduction about this project is that the energy is derived from fossil fuels is not sustainable in the long run. As such, it is imperative to integrate new methods of energy generation into society. So one of the leading methods of sustainable energy generation is the harvesting of solar energy, and that is important because as CO2 emission increases because we use coal energy and we use fossil fuels and stuff for energy, it is really bad for the environment. And so we need some cleaner form of energy. So that's why solar energy is a really good alternative for the future. Transitioning to alternate forms of energy can be a daunting task, with many claiming that would be like too expensive. But we have written a program to lessen this burden by providing information about the cost of solar panels installation based on their home size and their energy use. And the thing about this is that this program shows that it might seem too expensive, but in the long run, it's going to save people a lot of money. So it's good to switch to solar power.
Next, I'll be talking about the algorithm. So starting out, the user will select what state to conduct their calculations for. And then next, we will ask the user if they would like to input their monthly electric bill or monthly usage of electricity. So with this input, if the user chooses monthly electric bill, then ask the user to input the monthly electric bill. Else, the user will input their monthly power usage. There will be then a data validation from the inputted data, and to make sure that it's a realistic monthly cost. From this calculates the user's monthly and yearly usage, and then after that, we will ask the user if they would like to input the size of their building. If they say yes to this, user inputs the size of their building in square feet and how many floors. There will be a data validation to make sure that the positive values are entered so that they make sense, else the program will continue. The code will calculate and then output the amount of energy needed of the size of system needed. Then, the code will ask the user if they would like to apply the tax reduction for the selected state. If the user chooses yes, then the outputted graph will factor in the tax reduction. Next, outputs the cost of the system installation with and without the tax reduction and how long it will take to break even and start saving money. And it will also output a graph of how long it will take to pay off the system versus each system size. If the system needed does not fit on the roof, ask the user if they would like to choose a different system size for a suggested list. Else, the code will end.
So when you run the code for the first time, what it's going to do is it's going to open up a menu with all the states, and you're going to be prompted to enter a state. So in this case, we're going to click Texas. Then it's going to prompt us to input either the monthly cost of our electricity, or the monthly electricity usage, and using the average cost of electricity in your state, it'll calculate one or the other depending on which one you pick. So in this case, we're going to click monthly usage, and I'm going to enter down at the bottom 980 kilowatt hours, and it will automatically calculate our monthly cost based on the average use of electricity and calculate our yearly usage. So up top here, another menu is going to appear, and it's going to ask us whether or not we'd like to have our home size inputted, and this won't necessarily affect the code. It'll just provide extra data, and it will show you whether or not the solar panels that you're going to need to get your monthly usage of electricity is going to fit on your home size. So we're going to click yes, and then down here we're going to click 1,500 square feet for our home with 2 floors. So this is going to calculate our roof size, and depending on the roof size, you either will be able to fit the system size or not. So down at the bottom, it's going to tell us that we need 4 kilowatt system size, and then it's going to tell us that our tax reduction will bring the price down by around $3,000. Not all states do this tax reduction, so this is why at the top we have a menu. It's going to ask us whether or not we have a tax reduction. In Texas, there is no tax reduction, so we're going to use the base price. And then down at the bottom, you can see that it'll take us 78 months to break even, and then we will begin saving money. And using our roof size, it calculated that the suggested system size will fit on our home's roof. And in the right over here, our plot will show up, and this will be a plot of system size versus the amount of time it takes to pay it off. And this doesn't actually mean that you'll be paying money every month. This just means that it'll take you a certain amount of months to start saving money. And this seems like a big number, 78 months, but if you think about it, if you're living in a home for 20, 30 years, then you'll be saving quite a bit of money in the long run. Even though you'll be not saving money for 78 months, you'll still be saving money in the very long run. So as you can see, as the system size goes up, the price will go up, which in turn makes the payoff time go up.
If you run the program, the menu shows up as shown before, but if you do not make an option, the menu continues to appear until an option is made. We will again pick Texas. This time I'll input a cost, and if for some reason you accidentally input a negative number for how much you pay per month, it does not accept it. Also, it does not take words. So if you try and describe how much you pay with words, it is not accepted. So if you input the proper amount, it takes it, another menu pops up. Every menu we have set to keep appearing until a selection is made. Yes, we will input our home size. So if you enter a value, once again, that is negative, it will not accept it. But before it does that, it asks you to input your floors. It does this because if one is inputted correctly, it only asks for the incorrect one. So I'll say 2 floors as a correct value, and then it only asks for square feet because floors was a correct value. So I will once again say 2,000. And as I stated, it did not ask for floors again because it was an accepted value. So just another menu, just to show that it works with every menu that you have to make an option before you can move on in the code. And we're in Texas, so we're going to use the base. And then from there, it brings up the graph and tells you the suggested system size, how long to break even.
So by now you're probably wondering, what are some applications of this program in the real world? And for example, if you're just a person and you wanted to switch to solar power, this code will be useful to be able to tell you whether you can fully switch to solar power and start saving money based on how much room your building allows and how big your building is. And it will also tell you how long it will take once you install the solar panel system for you to be able to break even and start saving money on energy rather than how much money you'd be spending on the standard energy that you're already using. Also, if you're wondering for any limitations this program may have, we have some restraints to the accuracy of what we may output. For example, we are assuming that the roofs are assumed to be larger than the square footage of your home divided by the number of floors. And this is just to account for any like small things we may have missed. And another thing is the averages are based on state, not on region. So for example, we may be a little bit off based on where you're living, so you may have to take that into account. And also, this is really just for the United States, but if you ever wanted to use it for something else, like let's say Germany or some random country, you would just have to import the data yourself. But that is a limitation we have currently with this program. And also, we're assuming that constant sunlight exposure is assumed. For example, we're not assuming, hey, maybe there's a hurricane and you don't get this much sun this like week or whatever. And we assume that each solar panel has 100% efficiency, which isn't always the case in the real world, as we all know. And certain houses will not have a large enough roof size in order to install the solar panel system needed to fulfill their total energy needs. So you may need to account for that. So your house may not be able to install the solar panel system to fully pay for your electric bill, but it may be able to pay partly for it.
Thank you for watching our podcast over our program to find your suggested solar system size. I hope you learned a little bit about solar systems and what they produce and why they would be a good alternative to using fossil fuels. Thank you.